I mean, I want you to imagine a highly practical scenario for a second. You're sitting at your computer, or maybe you're just, I don't know, walking down the street looking at your phone.
Right, just going about your normal day.
Exactly. And you deploy an AI agent to go out and hire some kind of digital service on your behalf.
Like maybe you needed to scrape a massive data set for a project you're working on.
Yeah, or you needed to spin up and just like purchase some temporary server space. So your agent goes out into the digital wild, it pays for the service using a microtransaction over the Lightning Network.
And a few seconds later, it comes back.
Right. It returns to your screen with this cheerful little, success message. And it feels completely magical, like we are finally living in the future.
It really does. But then an uncomfortable question sort of creeps in.
Yeah, a very uncomfortable one. Because if you actually try to look under the hood of that specific transaction, can you answer, like, who technically authorized that specific spend?
Exactly. Or what budget was actually being enforced in that exact microsecond?
Right. What data was actually bought? Or, perhaps most terrifyingly, what would have happened if the payment route had just failed halfway through?
It's basically the ultimate black box. You see this polished result on your screen, but you have zero visibility into the actual financial plumbing that got you there.
And solving that black box is our mission on today's Deep Dive. So, welcome, because we're looking at a really fascinating collision of recent social signals, specifically from mid-May, alongside some heavy-hitting system design architecture for machine-to-machine payments.
Yeah, because the reality we are facing today is that AI agents can spend money right now. The underlying technology is already functioning.
But nobody actually knows who holds the receipt.
Right, which introduces this massive vulnerability into our daily workflows. I mean, we are essentially rushing to grant autonomous software the ability to execute irrevocable financial transactions.
Which is wild when you think about it.
Totally wild. And we're doing it without stopping to build the necessary infrastructure to hold that software accountable.
Okay, let's unpack this. Because to understand how we actually fix agent spending, we first have to look at how the broader internet is currently, misunderstanding the whole situation.
Yeah, they're missing the point entirely.
Because right now, the public narrative is obsessively focused on the rail-like, the payment network itself, rather than the rules governing the money.
What's fascinating here is just the sheer social momentum behind this misunderstanding. I mean, people love a flashy headline.
Oh, they definitely do.
And they get caught up in the philosophical debate about the currency rather than looking at the actual mechanical engineering of how machines negotiate.
Right. And what a headline it was. So on May 17th, there was this incredibly viral claim that absolutely exploded on Reddit, specifically over on the Our Bitcoin subreddit.
Yeah, I remember seeing that. It racked up, nearly 800 points almost instantly?
Yep, almost instantly. And the post highlighted an experiment where researchers gave 36 different frontier AI models. So we're talking the big flagship models from Anthropic, OpenAI, Google, DeepSeek, xAI, a very straightforward assignment.
They essentially told these models to act as autonomous economic agents.
Exactly. They said, choose how you want to transact with one another. And the headline that everyone ran with was that they all supposedly chose Bitcoin.
And the community response to that was essentially a giant victory lap, right? The prevailing sentiment was the machines have recognized the superiority of our currency.
Yeah, they were thrilled.
But if we look closely at the underlying data of that experiment, those AI agents didn't just magically fall in love with the cypherpunk philosophy of decentralized money.
No, not at all.
They simply optimized for the strict constraints they were given in their system prompts.
Right. Let me add some color to those constraints, because they're the whole reason for the outcome. The researchers gave the models parameters like, you have no corporate bank account.
Which is a pretty big hurdle.
Huge hurdle. And you cannot pass KYC. No customer identity checks, so no uploading a passport or anything. You need instant global access across borders, and you must use machine-readable rails, like APIs.
So when you feed those limitations into an AI, of course they landed on a permissionless digital currency. It's literally the only logical output for those specific parameters.
Exactly. I mean, a software program cannot physically walk into a Chase branch and sign paperwork to open a checking account.
Right. So it proves that permissionless digital money is a frictionless fit for software. It's native to the internet. But treating that viral claim as the end of the discussion is a huge mistake.
Oh, it's just the starting point.
Exactly. Because if we flip over and look at the other side of the social signal from that exact same day, the pushback was incredibly fierce.
Yeah, it really was. Over on the cryptocurrency subreddit, the reaction was a totally different flavor. Users over there pushed back hard on the narrative, basically calling it propaganda.
Which, to be clear to you listening, we're not taking sides in a crypto turf war here.
Oh no, never. Our focus is impartially breaking down the practical objections they raised, because the skeptics pointed out that a base layer blockchain just isn't fast enough or cheap enough to handle the billions or, eventually trillions of microtransactions that an agent-driven economy would actually require.
Yeah, they were demanding answers about transaction fees and bringing up huge concerns about network scalability.
Right.
And amidst all that noise about scalability, they asked the most vital question of all. How do you actually verify what an AI agent is doing with your funds?
And who is accountable when it inevitably makes a mistake?
Exactly.
Because giving an autonomous agent access to a bearer asset like Bitcoin is essentially like giving a teenager a massive stack of untraceable, non-sequential $100 bills instead of like a tracked debit card.
That's a great way to put it.
Right. Because the problem isn't the cash itself. The cash works perfectly fine for buying things. The problem is that you have absolutely no idea what they bought or where they bought it.
Or if a vendor just ripped them off entirely.
Yeah. And you won't know until it's way too late and the money is completely gone.
That is a phenomenal analogy. The payment rail itself, whether it's a layer 1 blockchain or a layer 2 solution like the Lightning Network, is entirely agnostic. It doesn't care why the money is moving.
It just moves the numbers from point A to point B.
Exactly. Therefore, logically, we have to build a rigorous system of rules completely around the money before we even think about touching the payment network.
Which brings us to the core of the system design architecture we are digging into today. Because the payment rail cannot solve the accountability problem, we need something systems architects are calling receipts before spending.
And to be clear, we're not talking about boring administrative paperwork here.
Right. We're not talking about saving your receipts in a shoebox for tax season.
No. We are talking about strict code-level systems architecture. A robust spending agent requires what developers call scoped authority.
So what does this all mean in practice for the user? Like, how do you actually give an AI scoped authority?
Well, it means the agent can't just be handed an open-ended directive to go solve this problem and spend whatever it takes.
Because that would be a disaster.
An absolute disaster. Before a single Satoshi or fraction of a cent leaves your wallet, the agent must be bound by exact, mathematically verifiable boundaries.
Okay.
It needs an absolute maximum budget encoded into its task. It needs a strict whitelist of permitted vendors or services it's allowed to interact with.
Right.
It needs designated checkpoints where it has to pause its process and ping a human for manual approval. And crucially, it needs hard stop conditions built into its core loop.
Let's walk through what that actually looks like in a workflow, because the design briefs lay this out in a very specific sequence. First, you have to record the instruction that actually creates this authority.
Which they refer to as the signed intent.
Right, the signed intent. You are cryptographically signing a digital statement saying, I authorize Agent X to spend up to $5 exclusively on this specific data scraping task, valid only for the next 24 hours.
And then you move to the handoff.
Okay, so what happens at the handoff?
The handoff is the critical transition point where visibility usually breaks down. In a receipts before spending model, the system has to record a comprehensive log.
Like a step-by-step record.
Exactly. What did the agent attempt to do? Who did it actually initiate payment with? What raw data or service was received in return? And did that specific exchange successfully complete the overall job?
Okay, I see.
This immutable log is the receipt. The parameters and the intent to log it must exist before the financial action is ever taken.
Okay, I have to pause and push back on this a little bit because this echoes a major concern from one of the technical signals we're reviewing.
Oh, the artificial intelligence thread.
Yes, the thread from artificial intelligence.
Yeah.
There's this highly upvoted discussion where working developers are pointing out a harsh reality.
Yeah.
Like 90% of what the industry is currently hyping up as agentic AI is basically just a glorified while loop.
Ah, yeah, the React loops.
Yes. React loops.
Oh.
And for those who aren't in the AI trenches every day, a React loop, which stands for reasoning and acting, is essentially just a language model wrapped in a tiny script that tells it to talk to itself.
It literally just says, try this action. Did it work? If no, think of a new action and try again.
Exactly. And these loops lack actual state management. They don't have true persistent memory of what they just did 5 seconds ago.
And they have famously terrible error recovery. They just hallucinate solutions when things break.
Right. So if that is the reality of the technology today, aren't we just attaching real, hard-earned money to glorified while loops?
Right.
Aren't we building a machine that has the capacity to just drain our wallets on repeat because it gets stuck in a loop trying to buy a broken API key over and over again?
That's a very real fear.
So how does an agent practically handle that kind of uncertainty without bankrupting us?
Well, if we connect this to the bigger picture, the sheer unreliability of a React loop is the exact reason why scoped authority is completely non-negotiable. Uncertainty only matters, and it only becomes dangerous if a software loop is actually permitted to act on it.
So walk us through the mechanics of that. How do we actually stop the loop from just firing off another request?
Let's say your agent hits an error, the vendor's API goes down, or a payment route is unconfirmed. The agent is now in a state of uncertainty, right?
Right.
If it's just a naive while loop with unfettered access to a hot wallet, it will do exactly what you fear. It will just keep firing payment requests, burning your money on network transaction fees or duplicate purchases.
Which is the nightmare scenario.
If the agent is operating within an environment that enforces strict signed intent, the wallet itself acts as the barrier.
Oh, interesting.
The mechanism holding the funds enforces a hard conditional logic. It sees the unknown state and instantly revokes the agent's authority to access the keys.
So the system cuts it off.
Exactly. The system will step in and say, you hit an unknown state. Your cryptographic access to this wallet is physically suspended until the state is resolved, or until you alert the human operator for a new signature.
Ah, I see. So the receipt, that scoped boundary you defined before the task even started, acts as a physical circuit breaker for the loop.
Yes.
So the AI can hallucinate all at once, but the wallet environment just ignores it.
Precisely. Because without those cryptographic circuit breakers, autonomy is just financial ambiguity moving at machine speed.
Okay, so we have firmly established what needs to happen before the spend. We need the budget, the boundaries, and the circuit breakers to stop runaway AI loops.
Right.
But let's say all of that is perfectly in place. The agent gets the green light, it has its signed intent, it goes to execute the transaction, and it uses a layer 2 solution like the Lightning Network to make sure the payment is fast and cheap.
Makes sense.
But then, things go wrong on the network itself.
Which happens constantly in decentralized networks. I mean, routing failures are just a feature of the landscape.
Right.
And this brings us to the next critical layer of trust, how the system interprets and explains that specific failure to you, the operator.
Because usually, when people talk about the UX, the user experience of the Lightning Network, they are entirely focused on making payments feel instant. They want it to feel like tapping a credit card at a coffee shop.
Right, that seamless experience.
But the system architects point out that for agent payments, the real UX problem isn't about speed at all. It is entirely about failure mode design.
Because right now, most crypto wallets and payment interfaces take incredibly complex, highly nuanced network issues and lump them all together under one massive, unhelpful, generic banner.
And that banner just reads, payment failed.
Exactly. Just payment failed.
It's exactly like tracking a package you desperately need. You check the courier's app and all it says is delivery failed. You were left totally blind.
You have no idea what went wrong.
Was the highway washed out by a storm? Did the driver get lost in your neighborhood? Or did the person at the front desk actively refuse to sign for the box? You can't make a rational decision on what to do next because the system robbed you of the context.
And in the world of machine-to-machine payments on a network like Lightning, those contexts are vastly different and require totally different automated responses.
So break that down for us. What does payment failed actually hide?
Well, when an app just says payment failed, what it might actually mean is a stuck route. The Lightning Network relies on multi-hop routing through various nodes.
Right.
If one of those intermediary nodes goes offline, the funds are temporarily locked in a network channel. That requires patience, not a retry.
What are the other failure modes that get hidden?
It could be delayed settlement, or it could be insufficient liquidity, which is basically like pulling up to a toll booth with a $100 bill and the operator simply doesn't have enough change to break it, so you're stuck.
Oh, that makes sense.
It could also be a custodial fallback issue, which is like handing your cash to a friend to pay the cashier because the store's card reader is broken. Or the destination might have actively rejected the invoice because the AI agent formatted the data request improperly.
Wow, so these are completely different mechanical failures.
Completely different.
And the average user shouldn't have to think in layer 1 and layer 2 technical vocabulary. Like, you don't need to know the intricacies of routing nodes or inbound liquidity channels.
No, absolutely not.
But the system, the overarching architecture, must preserve the distinction and translate it.
Right. This raises an important question for developers. How do you surface that specific distinction without overwhelming the user? Because only with that granular data can the overarching system logic decide what to do next.
So the system uses that error code to guide the agent.
Exactly. If it's a network path issue, the system can automatically command the agent to retry a different route. If it's a counterparty issue where the vendor actively rejected the payment, the agent needs to go find a different vendor entirely.
And if it's an authorization issue?
That means the agent actually tried to exceed its budget, and the system needs to pull the plug, cut off the wallet, and alert you immediately.
Right, because if the interface just throws up a generic payment failed error, you have no idea if the network is just a bit congested or if your AI is actively trying to embezzle funds from you.
Yeah, you lose the ability to make an informed trust decision. The black box remains closed.
Here's where it gets really interesting. We need a system that records scoped budgets, handles complex failure states without dumbing them down to uselessness, and provides auditable cryptographic receipts for everything.
Which is a tall order.
It is,
Yeah.
which forces us to ask, where does all this data actually live? Because if we put all of these receipts and signed intents on a centralized server controlled by a single tech giant like an Amazon or a Google, we have defeated the entire purpose of using permissionless networks in the first place.
We're just trusting a different middleman to not alter the logs.
Exactly.
And that is the ultimate architectural puzzle for this space. You need data persistence, you need encryption, and you need verifiability, but you need it without centralization.
And this is exactly why developers are turning to protocols like Nostr to tie all of this together.
Yeah, Nostr is really fascinating here. It's frequently misunderstood by the broader public as just a decentralized clone of Twitter, but at its core technical layer, it is much more profound.
Okay, so what is it doing under the hood?
It's a simple, open protocol that allows for the creation of persistent identities and the broadcasting of cryptographically signed messages, which the protocol calls events.
Let me try to break that down with an analogy. Creating an identity on Nostr isn't like making a username and password on a website. It is like forging a unique signet ring and a stick of wax.
I like that.
Every time you or your AI agent takes an action or sends a message, you stamp it in hot wax with your unique ring.
Right.
Anyone in the world can look at that wax seal and verify with absolute mathematical certainty that it came from you and that the message inside hasn't been tampered with.
That is exactly how it functions. It provides the vital missing pieces for agent accountability. You get persistent public and private keys, mathematically signed events, encrypted messaging between different machines.
And you get data trails.
Yes, data trails that can be published publicly for transparency or kept highly encrypted and private between you and your agent.
So let's map out how that framework actually functions for our listeners' workflow. You spit up your AI agent. First, the agent generates an identity on Nostr.
Right.
It gets its own set of cryptographic keys, its own signet ring. It is now a distinct, recognizable actor on the network.
And building on that, the task you want it to do, along with that scoped authority and the $5 budget we discussed earlier, is broadcast as a signed intent.
Okay.
You take your personal signet ring, you stamp the instruction, and you cryptographically say, I, the human operator, authorize this specific agent identity to act.
Then, as the agent goes out and interacts with vendors, every single handoff, every API call, every Lightning invoice it generates leaves an event trail on the Nostr relays.
It creates a breadcrumb trail of signed, verifiable actions.
And finally, we arrive back at the receipt. The final proof of the transaction on the network points backward to your original instruction, proving the AI was authorized to do it, and points forward to the delivered result.
Which proves the vendor actually completed the job.
Right. The massive benefit here is that delegated machine work becomes completely inspectable. You take this opaque black box and you pull it inside out.
You aren't relying on OpenAI's server logs to tell you what your agent did.
Exactly. The agent's work becomes highly legible because all the transitions, the instructions, the specific network failures, the payments, they're all signed, they're time-stamped, and they're completely portable across different software clients.
It really creates the foundation of a truly verifiable autonomous economy. You trust the cryptography and you trust the mathematically signed trail of events rather than just blindly trusting that a corporate database hasn't been altered or accidentally deleted.
So what does this all mean for the people out there who are actively building these tools right now?
Well, the pragmatic takeaway for builders is unambiguous. Do not start your project by integrating the coolest, fastest payment rail.
Right.
Do not start by just hooking up a language model to a Lightning node and cheering when it successfully buys a digital coffee. You must start with the receipt model. You have to design for auditability before you design for autonomy.
Because if you build autonomy without auditability, you aren't building a tool. You are building a massive financial liability.
You hit the nail on the head. Bitcoin and the Lightning Network might be the perfect frictionless rails for moving the digital money, and Nostr might be the perfect identity and event layer to track those movements.
But the real trust layer is the boring stuff.
Exactly.
Yeah.
The thing that will actually allow this technology to scale out of hacker experiments and into enterprise use in daily life is the strict financial boundaries. It's the automated stop rules. It's the granular, honest failure explanations. It is the receipts.
That is the only way agent money becomes usable and safe for the public.
Absolutely.
To you listening, I want to leave you with a highly practical challenge. Look at any automated workflow you currently use in your life or your business.
Yeah, take a close look.
Whether it's a simple Zapier automation connecting your emails, or a more complex AI agent that can commit resources or draft documents on your behalf. Ask yourself, if this system goes rogue or breaks down next Tuesday, can I perfectly reconstruct who originally authorized it?
Good question.
Can I see what its absolute limit was? Do I know exactly what failed under the hood and what cryptographic proof actually remains that I didn't just authorize an infinite loop of spending?
It's really a critical audit of your own digital exposure in an increasingly automated world.
It really is. And it leads to a final, slightly provocative thought to mull over as we wrap up. As these autonomous agents get vastly more sophisticated and they start executing hundreds or millions of microtransactions on our behalf in the background of our daily lives, will our own personal financial reputations eventually become completely entangled with the transaction histories of the bots we deploy?
Oh, that's a scary thought.
Think about it. In the near future, if you deploy an AI agent and it continuously fails to properly settle Lightning invoices or violates vendor terms of service, could that bot's messy digital footprint secretly destroy your own personal credit score?
Wow.
It is a brand new kind of financial identity, and we are just laying the tracks today. Thanks for joining us on this deep dive. We'll catch you next time.